Hello everyone, myself Nayan from Sri Venkateswara College of Engineering, CSE department. Today I am going to talk about the parameters animation involves in physics. The physics of animation. This presentation explores the fundamental physics principle that underpin and art of animation, showcasing how this principle can be used to create realistic and engaging animated characters and scenes. Newton's laws in animated motion. First law, inertia. An object at rest stays at rest, and an object motion stays in motion at the same speed and in the same direction unless acted upon by a force. This explains why characters keep moving even after a push. Second law, force and acceleration. The acceleration of an object is directly proportional to the force applied to it and inversely proportional to its mass. This explains how heavier objects require more force to move. Third law, action and reaction. For every action, there is an equal and opposite reaction. This explains how a character jumps by pushing off the ground with their feet. Friction and inertia in cartoon physics. Friction. Friction is a force that opposes motion between surfaces in contact. It's crucial for creating realistic movement like the resistance a character experiencing when running. Inertia. Inertia is the tendency of an object to resist change in its motion. In animation, inertia helps characters slow down or stop smoothly after a push. Mastering momentum and acceleration. Momentum. Momentum is the mass of an object multiplied by its velocity. It determines the amount of force needed to stop a moving object. Acceleration. Acceleration is the rate of change of velocity over time. Animators uses acceleration to make characters move realistic, increasing their speed gradually. Gravitational force and falling objects. Gravity. Gravity is a force that pulls objects towards each other. It's responsible for the downwards movement of falling objects and influences the motion of character. Free fall. In free fall, an object falls under the influence of gravity alone. This is used to animation to create realistic falling motion and create a sense of weightlessness. Terminal velocity. Terminal velocity is the maximum speed an object can reach during free fall during due to air resistance. This effect can be used to make falling object appear to slow down. Rotational dynamics in character animation. Angular velocity. Angular velocity is the rate of change of angular displacement over time. This helps animator create realistic spinning motion. Torque. Torque is a force that causes an object to rotate. It's used to animation to create twisting motion like a character turning a wheel. Moment of inertia. Moment of inertia is a measure of an object's resistance to rotational motion. It explains why heavier objects are harder to spin than lighter ones. Elasticity and deformation in cartoon. Elasticity. Elasticity is the ability of an object to return to its original shape after being deformed. Deformation. Deformation is the change in shape of an object due to applied force. It used to create visually appealing and exaggerated squash and stretch effect. Fluid dynamics and animated water. Buoyancy. Buoyancy is the upward force exerted on an object submerged in a fluid. Viscosity. Viscosity is a measure of a fluid's resistance to flow. This determines how fast or slow water moves. Surface tension. Surface tension is the force that causes the surface of a liquid to behave like a stretched elastic membrane. These are the thermodynamics and animated fire explosions. Applying physics principle to enhance realism. By understanding and incorporating physics principle into their work, animators can create realistic and engaging animations that captivate audience. These principles are crucial for bringing animated characters and words of to life. Thank you.